This is test number 5 from the series note, and this test is mainly based on relative motion. So the relative motion is really crucial. I mean, understanding the relative motion is really crucial, not only for this part but also for the rest of the syllabus as well. So if you clearly understand relative motion problems, I mean concepts, there are some questions, there are some shortcut methods that you can gain answers very quickly. For an example, if let's say you are given a question that two objects are moving simultaneously. If two objects are moving simultaneously, if you simplify that, if you approach that problem as usual using motion equations only, then that problem is going to be somewhat complicated. But if you understand relative motion concepts, when there are a bunch of objects, then that motion gets simplified. You can do very quickly those types of problems. That's why this is crucial to understand that relative motion concepts, right? Okay, moving on to the first question. If an observer moves at a constant velocity in a straight line, which of the following best describes how they would perceive the motion of objects around them? Motion of objects around them. Uh, so let's say you are the observer. So you are moving in a straight line at constant velocity. Let's say you are in a vehicle. So you are moving, so the vehicle and the you are moving in a straight line. So what do you see when you look around? You see that all those objects are moving backwards, right? So the relative to the vehicle you are in, you are at rest. You are at rest. But all the other objects are moving to the opposite direction. So always you perceive the rest of the objects around you, the objects around you, relative to you, relative to your motion, right? It will be more clear when we are discussing more and more problems, right? So that is the theory there. You perceive yourself as you are at rest. You only observe other motion of other objects. So always you perceive motion of other objects relative to your motion. Relative to your motion, right? So the answer should be second one. Observer should perceive motion of objects relative to their own motion. Relative to the motion of the observer actually, right? So it is second one. Just remember that concept. It will be clearer when we are doing more and more questions, okay? Before moving on to other problems, there's a basic concept behind relative motion. I have to explain that. It is in the theory notes, right? But I'll quickly explain that briefly. How to get a relative motion between two objects, between two moving objects, right? Let's say you have object A. This could be a vehicle or any type of object. And object B. A is moving to this side at v1 velocity. B is moving to this side at v2 velocity. You can only apply this method given that these velocities should be relative to Earth. In your normal calculations, up to here you have calculated, though you have applied linear motion equations. All those equations are applied considering that Earth is a reference frame, meaning you have applied all those equations relative to Earth, right? When they just say velocity, it is always by default, it is relative to Earth, right? Relative to Earth. Whenever they say just express about a velocity. If the velocity is relative to something else, then they mention that relative to that car, relative to that man, right? they specifically say that is relative to, if it is relative to other objects. If they just say velocity, it means relative to Earth. Okay, so these are just velocities. I'm not going to say that again. So these are just velocities. So you have to know these are relative to Earth velocities. I'll just mention that. So you can denote that like this: relative to Earth velocity of A. That's how we say it. Relative to Earth velocity of A is equal to v1. You have to write that with the directions, right? You must write with the directions. Then for this one, you can write relative to Earth velocity of B, it is to this side, v2. So move into the same side, right? Then there's this equation. What does this mean? Relative to B velocity of A. Relative to B velocity of A. Just put another object, which is Earth here, in between. So you can write this equation like this: AE plus VEB. VAE plus EB. AE plus EB. You must recognize this pattern. We did that. You know that from vectors, right? AE, EB. Since these are vectors, you can change this to BE and make it a negative. So VAE minus VBE, right? Okay, now we know that VAE is what? V1 to this direction. Minus VB is minus to this direction. So since these two vectors are to the same direction, you can just simplify that. So it becomes V1 minus V2 to this direction. Get it? So what does this mean? In MCQs, you can use this. Whenever objects are moving to the same direction, these are moving to the same direction, you can just take the difference of velocities. You can use this at once, right? In order to find the relative velocity between two objects, given that they are moving to the same direction, you can just take the difference of velocities, v1 minus v2, right? Then you can figure out the direction. I'm explaining this because this is going to be used for the rest of the questions as well. Remember that, right? When the objects are moving to the same direction, relative velocity between those two objects is the difference of their Earth relative velocities. Earth relative velocities. So that's it. Okay. Then another scenario is, let's say objects are moving to opposite directions. Like this. Opposite directions. Opposite directions means this also is opposite, right? This also is opposite. This scenario and this scenario. Both are opposite directions. Towards or away. Both are opposite directions. So I'll choose this one. Actually, I can use this equation here. I'll use this at once. VAB equals VAE minus VBE. If you write this one and keep simplifying that, you would end up with this one. So I'll directly use it here. What is VAE? V1 to this side minus VBE, V2, but direction is opposite. Then flip the direction. In order to simplify vectors, all the vectors should be to the same direction. So if you flip that, you get a negative here. That negative and this negative becomes minus minus plus. Now all the vectors are to the same direction. Now you can simplify. Got it? Now you get V1 plus V2. Now that's the relative velocity between these two objects. So what does this say? You have to remember this, right? Whenever you are doing MCQs, you can use this. If objects are moving to the same side, relative velocity between them is the difference of their Earth relative velocities. If the objects are moving to opposite side, like towards or away, then you just have to take the addition of those velocities. Then you can get the relative velocity. Addition here, difference here. You have to subtract here. Got it? Now keep it in mind, right? Which will be useful for all the remaining questions. You don't have to prove this, okay? Just remember that whenever you are applying that to a MCQ question, right? Okay, keep that in mind. We'll move on to second question. Maximum relative velocity between two objects is 100 meters per second. Minimum relative velocity between them is 20 meters per second. Their velocities are. So they say just velocities, right? Meaning they are Earth relative velocities. Earth relative. They are normal velocities, right? They are just Earth relative velocities. So let's say their Earth relative velocities are v1 and v2. v1 and v2. Okay. So in the first part, they ask maximum relative velocity. So the direction of these could be to any direction. They are not specifying any direction. So how can we get a maximum? Right? Isn't that like this? Like when they are moving towards each other, like this. When they are moving towards each other, then the relative velocity between these two is maximum. Let's say they move like this, v1, but v2 to this side, inclined at a theta angle. So this is not towards each other, right? But now what's the relative velocity? You get, here the relative velocity is v1 plus v2. You know that when they are moving opposite directions, you can just add them. So that is the maximum velocity is going to be. If you think about this one, what is the maximum velocity? You need to take the component to this side, v2 cos theta. You know that cos theta is less than 1, right? So when you multiply that by v2, you get less value than v2. So this is less. Okay. So this is the maximum velocity. So when the objects are moving towards each other or away from each other, meaning to opposite directions, then relative velocity between them is the maximum. Okay. So there is a value for that maximum velocity. So maximum velocity is v1 plus v2. The value given is as 100. Then they say minimum velocity. Minimum velocity is v1 minus v2. Okay. Directly just subtract. What is this v1 minus v2? v1 minus v2 is when the objects are moving to the same direction. Then you get the minimum relative velocity between them. So that value is given as 20. Now you have two simultaneous equations. You can simplify that and find v1 and v2. That's what they are asking. Okay. I'll explain that a bit more. Let's say you are moving on a bus, inside a bus. If you see a bus coming in from towards you, right? From front, bus coming towards the bus you are in. What do you see that bus has a higher speed? Why is that? You see, you are not seeing that you are moving. Your speed also is added to that bus. So you notice that bus is having a large speed. So you see that bus quickly approaching towards you. Okay. So they are moving opposite directions. Another scenario is, let's say a bus is passing your bus. How do you see the next bus passing you? you notice that that bus that is passing you has less speed, meaning you have to subtract. So there you notice the relative velocities, right? You notice the relative velocity of that bus, other buses. So to get the relative velocity, you need to subtract your velocity from the velocity of other bus. Okay. Okay. So this is maximum velocity between two. This is minimum velocity. Then you just have to simplify this. Just add these two. You get 2v1, 120. v1 is 60 meters per second. Then subtract these equations. You get 2v2. v1 cancels off. 2v2 equals, you are subtracting, right? 80. Then v2 is 40 meters per second. Okay. So these are earth relative velocities. Those are 60 and 40. So the answer should be fourth one there. Okay. Third question. When two objects A and B move towards each other, they get close 5 meters in every second. When they move to the same direction, they get close 1 meter every second. Velocities of A and B are, right? So let's say velocities of A and B are v1. These are earth relative, right? v1 and v2. Those are velocities of A and B, right? In the first case, they are moving towards each other. Moving towards each other. So what's the relative velocity? Just add them. Okay. So what does this mean? They get close 5 meters per second. 5 meters in every second. What does it mean? So that their gap is decreasing by 5 meters within each second. Within each second, gap is decreased by 5 meters. Isn't that the relative velocity? They are telling about relative velocity, right? If you clearly don't understand that, you can remember this equation. Relative velocity is equal to rate of change of gap. So let's say, so rate of change of gap. Okay. So the change of gap is 5 meters. It is decreased by 5 meters. Then you have to divide it by 1 second. So that is equal to relative velocity between them. So this is another way to get the relative velocity v1 or v2. So this is equal to 5. Then at the another case, when they are moving to the same direction, they get close, meaning they are closing on in their gap 1 meter per every second. So you know that this should be large, right? Otherwise this is getting away. So v1 minus v2 is equal to 1. Since they are moving to the same direction, you need to get the difference between velocities. Then the relative velocity is rate of change of gap, that is 1 meters per second. So in this question as well, we get a simultaneous equation. Just simplify those two. Just add these two. So v1 3 meters per second. Then subtract 2v2 equals 4. So v2 is 2 meters per second. v1 is 3, v2 is 2. So the answer is 3, 2, right? Third one is the answer. You can further think about these questions, right? If there are any doubts, the best thing is you need to think on yourself. So when you get it, when you understand these by yourself, whenever there's confusion, so that you never forget that, right? Right. Fourth question. Two men move to opposite directions with velocities 2 meters per second, 6 meters per second, starting from the same place. So let's say man A and man B starting from the same place. One has 2 meters per second, other has 60 meters per second. They are moving away. Then eventually their gap becomes 12 meters. So in the question ask the time required for this gap to be 12 meters, right? So that's what they ask. So once you understand these, this question doesn't take even a 5 seconds to solve, right? But to clarify everything about this question, it's going to take some time. But once you understand this, it's not going to take even 5 seconds to tell the answer, right? Actually, the answer should be 12 divided by 8. That is 3 over 2, 1.5 seconds. But just looking at the question, you can say the answer. But you need to understand the concepts behind this, right? Right, let's see. So when you draw these stuff, all these velocities, displacements are relative to Earth, right? All these are Earth relative. Earth relative. Everything is. So we call these diagrams Earth reference frame. So all the questions you have done earlier when you are doing linear motions, the diagrams, all diagrams you have drawn, they are Earth reference diagrams. Thinking that Earth is a reference frame, you have drawn all those diagrams. Here as well, these are Earth reference. These diagrams, Earth reference means these velocities are pursued by someone on the ground. Ground means Earth, right? They pursue these velocities. But the trick here is you are going to use relative motion. Let's see how to do that. So this is A, this is B. I'm going to find this. Velocity of A relative to B. Velocity of A relative to B. What is that? Now you can just say that at once, right? You don't have to apply that the large equation. That is velocity between A and B. Move into opposite directions. So you just have to add these two. You don't have to prove this, right? Directly apply that. What is the relative velocity? 8 meters per second. Relative to B means you can think B stops. Whenever say relative to B, then B stops. If you take an relative to A, then A stops. That's the advantage of using these, right? You can stop a moving object using relative motion. So relative to B means B stops. Now think B is stop. Meaning you are drawing this in the B's frame. This is B's frame. It is like you are on B. You are the observer on B. Right. So let's draw this sketch again at B's frame. So B is stopped, right? B is here. Only A moves in the B's frame. So A moves at 12 meters. only A has to do all the motion, right? Whole displacement is done by A in B's frame. But in Earth's frame, 12 meters is done by both A and B. But in B's frame, whole motion is done by only A. B is stopped. In B's frame, B is stopped. A is done the whole motion, whole displacement. At what velocity? Relative to B. That's what we found. 8. Got it? So everything in B's frame should be relative to B. Relative to B. What? Till you understand this might look confusing, right? But once you understand this, you can do these types of questions within 5 seconds without even writing anything. Okay? But before that, understand these concepts. Right. So in this B's frame, I'm going to find the time. B has moved the 12 meters at 8 meters per second. So then just apply this equation. Constant velocity, so S equals to T. So the displacement is 12, velocity is 8, time. So the time is 12 divided by 8. 12 has 4 threes, 2 fours. 3 divided by 2 means 1.5 seconds. 1.5 seconds. So when the time is, so once you find the time, then again you can apply. The time does not change, right? Time is regardless of the frame, time is the same. Time affects the same regardless of the frames, right? So here, in order for the gap to be 12 meters, the time is 1.5 seconds. The trick we did is we solved this equation in the B's frame. So when you think about B's frame, everything should be relative to B. Everything should be relative to B, right? It is easier to solve that in B's frame because you can stop the motion of B. Got it? If you didn't understand, just somehow you have to understand. It is very valuable to understand these parts, right? So the answer should be third one. You can watch this again and somehow understand these, right? Very advantageous. Okay, fifth question. Cycling traveling at 1 meter per second ahead of a motorbike traveling at 11 meters per second. So this is motorbike, and this is a cycle. It has 1 meters per second. And their gap, they say 100 meters. You can use normal equations as well without relative motion. But this is very easy. Time required for the motorbike to pass a cycle. By just looking at this, I can say the time is 10 seconds. Once you understand these concepts, 10 seconds. So here what do you have to do? Apply relative motion. Here the motorbike is moving. Here the motorbike is moving, right? I can stop the motorbike or the cyclist. Motorbike or the cyclist. Right? So this is how you have to think that. If you stop the motorbike, so first find the relative velocity between these two. Let's say cm. I'm thinking about whether should it be cyclist or the motorbike. I'll stop the motorbike. Okay. So since these are to the same side, you have to subtract the velocities. Meaning 1 minus 11. 1 minus 11. I did that because you have to subtract these two, right? Since they are to the same side. So what do you get? 1 minus 11 means minus 10 to this side. Then make it a positive, make it to the other side. So in this question, I have stopped the motorcycle. And the relative velocity between them is 10. Once you stop the motorcycle, motorcycle is stopped, cyclist has to do the whole displacement, that is 100 meters, right? Then just apply ut. So cyclist has to, if motorbike stopped, cyclist has to move to this side or other side. Should be other side, right? If it is like small, if there's like a confusion, you can use this original equation. I think we won't have to use that. This is the original equation. Then from that equation, you can figure out that those directions. But here we are using a shortcut method. Anyway of the directions, we know that we need to get difference of velocities since they are moving to the same direction. If it is difference of velocities, you know the difference of velocities is 10, right? So the cyclist has to move, has to do 100 meters at 10 meters per second. Then apply S equals ut. So we are doing this question in the frame of motorcycle. So cyclist has to do 100 meters. Velocity 10 and the time. So the time is 10 seconds. Okay. So if you want, you can draw the motorbike's frame. You don't have to think that much, right? You already got the answer. But this is for further clarification. Motorbike's frame. Okay, so motorbike is here. It is stopped, right? So motorbike is at rest. Cyclist is moving 10 meters per second, and it does the whole motion of 100 meters. This is what is pursued by the motorbike, right? This is M's frame. You don't have to draw it even. So what are the steps? Just find relative velocity between those two. Then you know the distance. Then you know one object stops completely. Then you know the gap. Then gap divided by that velocity. You get the time. First one is the answer in the fifth question. It takes a lot of time to explain these questions, but once you, it doesn't take a lot of time to solve these questions, right? Once you get these ideas, right? Then the sixth question, two objects A and B moving towards and their gap is S. Distance from A to their meeting point is. So you know when they are moving face to face, they would meet somewhere here. So what they ask is this distance to the, this is the meeting point, distance to the meeting point from A, right? A is what they ask, right? So what are these steps? First find relative velocity. Here I am taking relative to a velocity of B. So obviously we know the magnitude of the relative velocity should be V1 plus V2. So if you, direction is not necessary here, but I'll explain how to get the direction. We know that A is stopped, right? If A is stopped, B has to move to this side. So the relative velocity of B should be to this side. So that's the velocity. And what should be the time? B has to do all the displacement because A is stopped. So this S is just S. Relative velocity is v1 plus v2. Then you can find time. Time is S divided by v1 plus v2. If you want, you can draw A's frame. A's frame. I think just for practice, you can draw it separately, right? I'm not going to draw it. Right. So this is the time it requires for these two to meet. But it is not what they ask. They ask this A, distance to meeting point from A. Now get back to the Earth's frame. This is Earth's frame. They are asking something about Earth's frame. But in the Earth's frame as well, we know the time. This time. Then just apply, let's say S dash. Here we took it as simple A. So S equals ut. So simple A should be what? Now in the Earth's frame, A moves at u. What's the time? We found that time. S divided by v1 plus v2. So us divided by v1 plus v2. So that is A. A is a distance, right? Not acceleration. A is the distance. I have taken it as a distance. I can explain this further, but this is what you have to do basically. Right, 7th question. Passenger moves 1 meters per second to opposite direction inside a train, which is moving at 25 meters per second. Velocity of passenger relative to Earth is. Okay. There's a slight difference in this question compared to the previous questions we discussed. There's a slight difference. So there's this train. So the train is moving at 25 meters per second. So what is this? When they say train is moving at 25 meters per second, it is relative to Earth, obviously. A train is moving at this velocity relative to Earth. Okay? Even though they don't mention it, you have to understand that is relative to Earth velocity of train. This is how we write it, 25 meters per second. Then there's a passenger. Passenger move into opposite direction at 1 meters per second. So let's say this is the passenger. Move into opposite direction at 1 meters per second to this direction. What do you think? They don't mention it. To relative to what, right? But when we say, so the passenger already is in the train, right? Passenger already is in the train. So you have to understand the velocity of this passenger is relative to the train. So that's how they ask questions. Not relative to Earth, relative to train. So someone inside the train sees that passenger moves to this side at this velocity. Relative to train velocity of passenger. So that is 1 meters per second. So we have these two velocities are not relative to, both of these are not, this one is relative to Earth, this one is not relative to Earth. So in that case, you cannot use that if it is opposite direction, just add it to the same direction, subtract it. You can only use given that all those velocities are relative to Earth. But here you have one of the velocities that is not relative to Earth. So you have to go for the fundamental equation. This is the fundamental equation. So what they ask is velocity of passenger relative to Earth. Then put the train in between. You get PT plus VTE. So what is PT? 1 meters per second to this side. TE to this side 25. Okay. Then this is just a vector calculation. change the directions. You can put a -1 here, 25 to this side, then 24 to this side. So this is the 24 meters per second. Do you notice the difference? Don't apply the previous one. Those can be applied only if all those velocities are relative to Earth. But here there is a one velocity that is not relative to Earth. So you have to start from the basics, this equation. Okay. Then you can simplify and get the answer 24 meters per second. See, these velocities are opposite, right? But you didn't add them. But once you get used to this, you automatically will get the answer. There's another way to think about this, that as the train goes 25 meters to this side, passenger inside the train moves 1 meters to opposite side. So relative to Earth, the distance passenger has moved is 24 meters, right? If train moves 25 meters, and the passenger moves inside the train 1 meter to the backward, how much is the distance the passenger moved? Should be 24 meters, right? You can think in that way, or else you can use equations. So the answer is first one. Right. Eighth question. Two trains with speeds 40 kilometers per hour, 20 kilometers per hour towards each other. Okay. So train A, train B. I'm not including the length of the trains because they haven't specified any lengths, right? So you don't have to, even though the train is long, you don't have to think about the lengths of trains, right? But if they mention the length, you have to think about that. So I'm considering trains to be point objects. This has 40 kilometers per hour. Another one has 20 kilometers per hour. And they are moving towards each other. Then there's the bird. The gap between them is 120 kilometers. Gap between the trains is 120 kilometers. Then there's a bird as well. There's a bird. I'll say capital K, not MK, capital K. So what does the bird do? He just moves from B, then A, B, A, like that. The bird is moving between A and B. The question they ask, as these two trains collide, so let's say they collide somewhere here, how much is the distance that bird has moved, right? So the first thing is you need to find the time required for these to collide, these two trains to collide. How do you find that? First thing, find the relative velocity. I'll say relative to B. You just have to add these velocities because moving to opposite directions. Why I'm using this? Because these are Earth relative, right? Both. So you get 60 kilometers per hour. Then find the time. So here you have stopped B. Then A has to move 120 kilometers. Apply U. T. Distance traveled by A is 120 in B's frame. And the velocity in B's frame is 60. Then the time. So you get 2. Just 2 hours. So within 2 hours, these trains would collide. So while those trains are approaching, the bird has been moving between A and B throughout, within these 2 hours. So how to find the total distance that bird has moved? Just apply S equals to to bird. Bird, right? I said bird as K. So the velocity of bird Is it given? Velocity of bird. It is given as 50 kilometers per hour. So the velocity of bird 50. Time is, we found that 2 hours. So how much is it? 100. So it is 100 kilometers. So the answer should be second one. Answer should be second one. Right? So in these questions, I'm jumping from between Earth frames to other frames like that, right? You have to notice that I'm not mentioning it every time which frame you are referring to. I think now you can understand which frame I'm saying, right? Okay, ninth question. A sitting on a trolley moving at V drops a ball. So he's dropping a ball, and this whole thing is moving at V. And there's a B. He's on the ground, right? So what they ask is how do they perceive the motion path of the ball as it drops to the ground, right? Okay. For both A and B, they don't have a vertically downward velocity. Vertical velocities same for both A and B. So to vertical direction, both A and B will see the same thing because they have the same vertical velocities. Neither he nor he, neither A nor B moves vertically. So what they perceive of the ball vertically will be the same. They will, what would they see? To vertical direction, both of them would see the ball just drops. A also would see the ball just drops. So what's the difference between A and B? A has a horizontal velocity V, but B doesn't have a horizontal velocity. Right? First I'll think about B. So to vertical direction, this is what's seen by B. This is not the whole motion of the ball. This is only vertical motion of the ball. As A releases the ball, we know whenever you are releasing something, sitting on a moving vehicle, initial velocity of that object, once he releases that, should be the velocity of that vehicle. So the initial velocity of the ball is this one. Since B doesn't have a velocity to this side, he would see the velocity of ball to this side. So he would see these two. So you can see it is a projectile as perceived by B. But if you think about A, vertical velocity is seen by A like this. What about horizontal velocities? Both A and ball has the same horizontal velocities. Then what should be the relative velocity between A and the ball horizontally? Since these two are the same, V minus V, because to the same direction, V minus V, 0. So to this side, there's no velocity. So A perceives the ball just drops. B perceives ball is in a projectile motion. So this is the full description, right? There may be shortcut methods. Some students might even remember this question. This is a past paper question. So this is the full description what's happening there, right? Full description regarding relative motions. Relative motions. So the answer should be second one, right? Second one. Right. 10th question. On floor of a train moving at 30 meters per second. So there's this train. Actually, this is the top view of the train, right? Let's say someone observing from top of the train relative to the ground, right? Let's say from a bridge or something. Velocity of train is given as 30 meters per second. So it is obvious that the velocity of a train is relative to the earth, right? Velocity of train relative to earth, 30 meters per second. Then a passenger inside the train rolls over an object to this side. So let's say you are on the train and you see the flow of the train and you are rolls over an object on the floor at 60 meters per second. What do you think? To what should this be relative? So you observe this sitting inside the train, right? So this velocity should be relative to train, not relative to earth. Relative to train, velocity of the ball. So this is related to train velocity. Okay. So in those cases, you need to go for the basic equation. In the question they ask velocity of ball relative to earth. Velocity of ball relative to earth. Put capital T in between. VBT plus VTE. So what is BT? 16 upwards. TE 30 to this side. So we have two velocity vectors to different sides. So how do we find you have to find the resultant of these two. 16, then the other side 30. Just draw parallelogram. 30 to this side, 16 to this side. Then the diagonal gives us the value of VBE. Magnitude of VBE. They are not asking about, I think they are not asking about directions, right? So they are just asking about magnitude, which is the length of the diagonal. So how do we find? Just apply Pythagoras. 16 squared plus 30 squared root 256, right? Plus 30 squared means 900 root 6, 5, 11, 1156. When you take the root of that, it is 34. Okay, third answer. So even though the ball moves to this side, relative to the ball moves perpendicular like this, but it is relative to the train, right? So that is someone inside the train observes ball moves like this, but relative to earth, ball moves actually to this side. Ball moves actually to this side, but that is relative to earth. Okay, so the answer third one. Once you get used to these, you don't need this much time, right? To explain it takes time because I need to go with the fundamentals, but once you get used to these types of questions, you don't even have to write this much, right? You can quickly get the answer. So in the exam, that's the level you need to go. That's the expertise you need. Right, 11th question. A trolley moves in a straight line at 30 meters per second. So there's this trolley, right? And the speed of the trolley, they say 30 meters per second. An object should be thrown from the trolley, so it will fall on the trolley. Once it completes a 90-meter distance, right? So the trolley moves from here to here. So the object has to move like this. So what they ask is initial velocity of the object relative to the trolley should be, right? So this is a somewhat tricky question and a great example to understand relative motion concepts. By looking at this, someone would say you have to throw the ball to a direction like this. Otherwise, it won't fall on this here. It's not true, right? So if you are on the trolley, you have to throw the object vertically upwards. Okay? I mean, relative to the trolley. Relative to Earth, you have to throw like this, to a direction like this. But relative to the trolley, you have to throw the object vertically upwards. So to clearly understand this, let's say you are on a train moving rapid, I mean at a high speed, right? So you are on a train moving at a very high speed, let's say 200 150 kilometers per hour. Doesn't have to be a large speed, but so you are in the train or a vehicle, right? Train is better because it has a constant velocity. So you throw an object like this, right? Sitting inside the train, you object. To which direction do you throw the object? Vertically upwards, right? So the object lands on your palm, on your hand again. But you know that train is been moving while that object is moving upwards. Train is been moving. But if you thinking that, but if you throw the object like this, it will never land on your hand, right? It will move to this direction. So the same thing here. So if you are inside the trolley, you have to always throw the object perpendicular to the trolley, flow of the trolley. Then the object will always land on the trolley. Got it? So it should be 90 degrees. You can think more about this, right? The more you think, the more clearer these concepts will be. So 90 degrees it is. Then the another requirement. So we know the direction to be shot upwards. Another requirement is the object has to land on the trolley back once it moves a 90-meter distance. While the trolley moves 90-meter distance, for this to happen, while the trolley is moving 90 meters of distance, the object should be in air. So first let's find how much of a time should the object be in air. So for that, just apply S equals ut to trolley. So this is 90, this is 30, t. T is 3 seconds. So for 3 seconds, the object should be in air. Then just apply this equation upwards to the object or the ball. So it goes up, comes down, right? Vertical displacement is 0. Goes up, comes down. Initial velocity is what you need. The time is, it should be for 3 seconds in air, half goes under gravity, so minus 10 t squared, right? 3u 5 minus 5t squared. The time is given, right? So it is 3 squared. Take it to the other side. 5 times 3 squared means 9 equals 3u. So u should be 15 meters per second. right? So 15 meters per second, and it is projected at 90 degrees. Third one, right? 12th question. A river flows south at 4 meters per second. So so this is north, and you have south here, east, and this is west. You need to know this. Those are the directions. River flows south. So river flow to this side, 4 meters per second. So obviously, let's say water, river has water, water is flowing, right? So the W. Relative to earth, it is obviously to earth, 4 meters per second and downwards. A boat heads directly east. East means this side. But it is relative to the water. Relative to water, boat is moving east. 3 to this side. So boat is like moving to this side, right? But it is relative to water, not relative to earth. That's why I didn't specifically mention a direction here. It is relative to water. What is the boat's speed? Relative to, and observe on the river bank. River bank means that is earth, right? I mean, river bank is at rest with the earth. So river bank relative to river banks means relative to earth. So this is what they ask, velocity of boat relative to earth, that is river bank. Just put, because now these are not, all the velocities are not relative to earth, so you have to apply basic equation BW plus VWE. What is BW? 3 to this side. WV 4 to this side. Now these two are two vectors, then we just have to take the vector addition there. Draw, if you want, you can draw. Actually, it should be 5, right? 3 here, 3 to this side, 4 to this side. Then you can draw a rectangle. The diagonal gives us the magnitude. So 3, 4 means the magnitude should be 5. So the magnitude of VB should be 5 meters per second. Here they are not asking about direction. So if they ask direction, you need to find this theta. So tan theta is 4/3. You need to find that if you want that, right? So the answer should be third one. Right. 13th question. A cyclist is riding at 12 meters per second east relative to the ground. Ground means earth. So east, right? East means this side. Let's say there are two cyclists. Let's say because it is cyclist, velocity of cyclist relative to ground, which is earth, moving to east. That is 12 meters per second. So C is first cyclist. Then there's a wind blows at 5 meters per second. Blows at 5 meters per second west. Then there's a wind as well. So the cyclist move into this direction. There's a wind flow into opposite direction to west. So let's say wind W related to earth is ground. What's the velocity? 5 meters per second. Then there's another cyclist. Let's say that cyclist is capital B. So that is second cyclist, right? Don't mix things up. So the second cyclist B, It's his relative velocity is 10 meters per second to west. So what they ask is relative velocity of second cyclist. Second cyclist mean B, velocity of B with respect to C, meaning relative to C. Velocity of B relative to C. Then you can put, if you want, you can put wind here, or else you can put earth, because everything is in earth terms, earth velocities, you can put earth there. So VBE plus VEC, VBE, make it CE, and you get a negative there, VCE. VB is what? 10 to this side, VCE 12 to other side. Okay. Then you can flip this to the other side, 10 to this side, minus minus plus 12 to this side. So the same direction, add these two, make it 22 meters per second to this direction. So what's the answer? First one, right? 22 meters per second to west direction. So in this question, they have mentioned about wind, but to get the answer, we didn't use that, right? But if they ask something else, the wind velocity might have an effect on this, but here it doesn't. Okay. Right. 14th question. An airplane flies at 300 kilometers to east in still air. In still air. Still air means air at rest. So whenever there is still air or rest, or if something is rest, meaning of that is relative to that thing, right? So here that velocity is relative to air. So let's say I'll take air as wind, right? I'll take air as wind. So I'll put air as W. So airplane, capital A. Then earth is capital E. Ground speed means relative to earth speed of the airplane. Is what they ask. Airplane flies 300 kilometers per hour east to this direction. So V relative to earth, or not relative to earth. In still air means whenever they say in still air, that means relative to air. Here I put W for air, right? So that is 300 kilometers per hour to east. If it encounters a wind means actually it is air, right? Blow wind 50 kilometers from the north. From the north. So that is velocity of wind relative to earth. It is relative to earth, right? From the north means to the south direction, 50. What is the airplane's ground speed? Ground speed means earth relative velocity of airplane. Airplane are used as A. So A, just put a W in between. W plus V, W, E. So what is AW? 300. WV, 50. Then to simplify this, you need rectangle, right? So the diagonal gives us a velocity. So it is a 300 to this side and 50 to this side. And you need to get this length. So this length obviously should be larger than 250. Okay, this length, I mean, it should be larger than 300. Should be larger than 300, but less than 350. So it is 300 squared plus 50 squared. Root of that is the answer, VAE. You can take 50 squared out and make it 50. Here you get 6 squared, 36 plus 1, 37. So this is 37 root means 6 point something, right? 6.1 something, 6.01 something. Because 36 root is 6. 37, it is very close to 6. So 50 times 6 something, right? Very close to 300. You need to get an answer close to 300. Cannot be 350. So the answer should be third one. Okay. Right. 15th question. A spaceship is orbiting Earth at 8 kilometers per second to east. So spaceship, I'll take it as capital S. Then there's a satellite, I'll take it as capital T. Satellite. Spaceship, and it is moving at 8 kilometers per second to east direction. That is obviously relative to Earth, right? 8 kilometers per second to east, this direction. It releases a satellite. So the spaceship releases a satellite at 2 kilometers per second. In the question says relative to spaceship. Relative to spaceship, satellite is released at 2 kilometers per second. To opposite direction. Opposite means to west. At the moment of release, what is the velocity of satellite relative to observer on Earth's surface? So what they ask, velocity of satellite, capital T, relative to Earth. Relative to Earth. Okay, just apply the same equation there. Or they ask VTE, relative to Earth, velocity of satellite. Just put S here. TS, VSE. So TS is what? 2 to this side. SE to this side, 8. What is that? 6 to this side, right? Kilometers per second. 6 to east. That is second answer.